half-lives. Woohoo! How many in here have discussed half-lives in some math class? Okay. So half-life, who can tell me what half-life represents? Okay, so I'm glad that you guys discussed it in math class because you have no idea what you're talking about. Half-life is an amount of time. Okay. Half-life is an amount of time. What that means is it's going to be the same exact amount of time, and let me scroll to this graph here, where I'm looking at strontium 90, and it has a half-life of 29 years. What that means is, after every 29-year period, whatever amount we originally started with, we have exactly half remaining. So after one half-life, if we start with 10 grams, we now have 5 grams. After a second 29-year period, or another half-life, if we have 5 grams, then we have 2.5, and so on and so forth. So it doesn't matter how much of the material you have, it's the amount of time. And it'll actually change what you start with to half of the original material will still remain. Okay. What's that? The nature of the reactant, different factors like I know that uranium has a half-life of over 3,000 years, where some things have a half-life of like 5 seconds.
And the math I did, we had one that was like 4.6 million years.
That's, yeah. You'll have a question similar to that. Yeah, so it takes that amount of time for half of it to change. And in this case, we would say decay for nuclear reaction.
I think it'd just be easy to find, to be honest, rather than wait for 4.6 million years.
Okay. Now, let's go to the practice problems. Ready? Did everybody get the blanks there? Was that a good lecture? You like that one?
Wait, what lecture?
Everybody had the blanks, blank, whatever. All right. So looking at the first practice problem. Okay. And before we actually do the first practice problem, let me give you some equations. Now, the equation that I'm giving you, I will give you, but you'll have to know how to use it. So for half-life, we will use this, which is called mass, which is typically in grams, and you'll have 0.5 to the n. Or some of you might want to write it as 1/2 to the n. Okay. Now the n represents the number of half-lives. To determine that, you take the total time and divide it by the half-life amount of time. Okay. So what this is saying is, once we figure out how many half-lives we have, we plug it into our equation. This is an exponent. And what we never do is we never round n. Whatever the value is, leave it in your calculator. And a lot of you have answer buttons. Utilize your answer button. All right. And again, the 0.5 or 1/2. Normally, I used to write it like this, the 1/2, but this is how you're going to type it on your calculator. So, that guy. Yeah, we'll push it down there. Get out of here. All right. So, looking at the first practice problem, it says a certain nuclei has a half-life of, we'll say, 30 seconds. What fraction or percent of the original nuclei would remain after 5 minutes if you began with 200 grams of the nuclei? And then it says, calculate how many grams would remain at the end of 5 minutes. So we have 30 seconds and 5 minutes. So if we're going to do this, we have to have the same units. So what do you want to go with, minutes or seconds? Okay. And it doesn't matter which one you go with. So if you go with seconds, then our total time in this case would be what? 300. So it's 5 times 60 seconds, if you want to do that mental math in your head. So that's 300 seconds. And what is the half-life amount of time? 30. So 30 seconds. What happens to the unit here? Gets canceled out. So when we talk about how many half-lives, it's not like 10 seconds. No, it's actually 10 half-lives. Okay. So let me move this over. right, so when we plug this into our equation, scroll this up a little. Okay. So we'll plug in, what mass did we start with here? 200 grams, so we'll go 200 grams times 0.5, and how many half-lives did we have? 10 to the 10th power. So to type this in, so I would go 200 times 0.5. A lot of you have this caret button. Some of you have a YX button. Some of you have a X with a shaded box button. Those all represent a caret. And then put your 10 in there. Sorry about that. And it should be a really small number because we're going through 10 half-lives. 0.195. Okay, that's good enough. Okay, so we start with 200 grams. After 10 half-life periods, then we only have 0.195 grams of that. Now, you could do it the really long way as well. So if you start with 200 grams, after one half-life, you have 100 grams. After another half-life, you have 50 grams. After another half-life, you have 25. You could do that 10 times. That'd be ridiculous. Don't do that. Yeah. And as you do this 10 times, so there's the first, second, third. I only went through 3 half-lives. Okay. Yeah, Kate. Oh, the 300 came from the 5 minutes. So we want to make sure we have similar units. So the half-life amount of time was 30 seconds, and the total time was 5 minutes. Okay. All right. Wasn't that fun? Oh, let's answer the question about the fraction or percent. So let's do the percent. Here, I'll move this guy out of the way. Actually, let's move it down for the next one. So the percent, if I finish with 0.195 grams, and I started with how much?
Oh, you started with 200.
200. And then multiply that by 100. What percent would I get there?
You have to do this percent, or are you just showing us how to do it?
No, it asked for it. So 0.0975.
Yeah.
Okay. And that is percent. So a lot less than 1% remaining, which makes sense. Now, let me ask you a question. If we started with not 200 grams, but say 5,327 grams, okay, after 10 half-lives, would the percent be the same or different? This is a good concept question. I like this. Same thing, same half-life amount of time. So after it undergoes 10 half-lives, will it still be this percent? Yes. Okay. So that's the nice thing about half-lives, because it's giving a finite number here, and it doesn't matter how much we start with. We're still going to plug that value in and then plug it into the equation. We'll still have that amount. Okay. And it says a certain radioisotope started with a mass of 333 grams. Calculate the mass of this radioisotope after 7 half-lives have elapsed. So how would we go about solving for this one? Good. So we'll use our 333 grams times 0.5 caret 7. Good. Super easy. I like that. Plug and chug. The way God made it. So 2.6, we'll say 0. Thank you for agreeing. Everybody good? Ready for the next one? Oh, we got one more. Oh, you mean for this one? Yes.
How about we just have all of these on the test?
Oh, it would be sad if you failed. Oh, yeah, here we go.
Let's write a book. It's a novel.
This is why you got out of bed this morning. All right. Thorium-231 has a half-life period of 25 1/2 hours. You perform research in a chemical lab, and you need to order 100 grams of thorium-231 for an experiment. Determine the number of grams that you will need to order of the parent thorium-231 sample so you can receive the 100 grams of thorium-231 for your experiment you're about to perform on your research. You plan on performing the experiment at noon on Thursday. Actually, we have to push it back a day to Friday. The chemical supply company can promise delivery of the material from Brazil, the country, not Indiana, in exactly 48 hours.
How much of that stuff can we just cross out?
I wouldn't cross any of it all. Any of it out. This is all gold. This is all gold. All right, so let me ask you a question. So you are...
You're going to need a lot.
Oh, why?
Because the half-life is 22.5 and you're going to get it in 48 hours.
Okay. So if I need 100 grams of it in 48 hours, if I order 100 grams of the material, will I get the 100 grams in 48 hours? No.
No way.
So the 100 grams is what I need. So if I'm going to order it, should I order more or less?
More.
There you go. So that's how much we need to figure out how to order. Okay. So here's how we do it. And I'll come back to this here in a second. We're not going to use the equation where you have mass times 0.5, or better written, 1/2 to the n. But what should we do?
A equals total time.
Okay, so here, let me throw this scenario at you. If we start with 100 grams and we undergo a number of half-lives, what happens to the sample size? It gets smaller, okay? And so we would have less than what we started with. So if I need to order this, is this a good equation to use?
No.
How should we rearrange that equation? Exactly. We're going to take the inverse of this. So if I take the inverse of 1/2, what does that equal? 2. When you take 1 divided by 1 divided by 2 and type that in on your calculator, 1 divided by 1 divided by 2, it probably wouldn't work because you'll have to do this. 1 divided by parentheses 1 divided by 2. What does that give you? 2. Yeah. So instead of using this equation here, we will use this equation. Here, let's use a different color. Let's go. Mass times 2 to the n. Okay. So whenever you need to have more than what you're going to use that second equation. The n still is the same. So it's still, the n is still your total time over your half-life time. Okay? So nothing changes. All right, so easy, bam, bam. So how much do we need?
800.
We need 100 grams of it, and our half-life amount of time is 25.5. So let's do that.
48 divided by 25.
100 grams times 2, and let's do our n calculation. So 48 is our total time, and 25.5. Now, we don't want to round this number. Okay, whatever you get, use that. Okay, so 1.8.
82352
Okay.
Don't round it.
Round it.
Why would we write the entire number?
It's going to cause a lot of people to have some conniptions here. Thank you. All right, so my calculator says 1.88235291. Okay. So we need to put that number without retyping it here. have an answer button.
I'm gonna do
So-
it. I can't do it.
Yeah, I don't trust that answer button.
You should. So here's how you would go about calculating this. Do 48 divided by 25.5. Get your number. If you have a calculator like a TI, okay, so you type 100 times 2, caret, second, and then this says answer down there. And a lot of calculators just say ANS has its own answer button.
Okay,
Just go ahead and just type in 100.
So 100 times 2, caret, answer. And it says 368.6758.564.
368.675.
So we're going to say 369. Show me your calculator. You got a what? Well, let me see. Okay, so it's second, and then it's the minus button. See a little A and S above it? There you go. So the answer button will give you the last calculated value. So you can type all this in and then hit your answer button, and it'll still retrieve this value for you. You should never, ever retype values into your calculator, especially if it's the last thing that you just calculated. Okay. So 369 is how many grams that we're going to have to order. Does that seem reasonable?
No. Oh, yeah.
Yeah, because we're almost going through 2 half-lives, and if we go through, say, if we're going in the opposite direction, 100 to 200, if I go through another one, then 200 to 400, which is just shy of that. So again, think about how logical your answer is when you're actually doing that. Okay.
Homework now.
The 3s are your homework.
Thank you.
Life is good. Any other clarifications? Amen.
You know, until you die from all the
3,
radiation.
2, 1, bye, video.
Blue.